Alright, so this is number 5. Number 5. What do we got? 1 over t plus 1 over 5t equal to, I'm sorry, not equal to, but plus 1 over 7t, all of this equal to the whole number 7. Alright, first job is always to find the lowest common multiple, better known as the lowest common denominator, whichever. I need a factor of t. Okay, this guy says 5t, I need a factor of 5. I need a t, but I've already got a t. Alright, here I need a factor of 7. I need a factor of t, but I've already got one of those. And that's it. My lowest common multiple is the product here. It looks like t times 5 times 7 is 35t. Alright, so I need to take this lowest common multiple and multiply it times each term in my equation. So 35t times 1 over t plus 35t times 1 over 5t plus 35t times 1 over 7t equal to 7 times 35t. Alright, we lucked out here. I mean, 7 times 35, fairly large number, but we lucked out that all these guys were positives. We have to move the minus sign up. Alright, the t's cancel out here. 35 times 1, well, that's just 35. 5 into 35 goes 7 times. The t's cancel out. So that's 7 times 1. That's a positive 7. The t's cancel out. I got that. 7 to itself 1. 7 goes into 35 5 times. 5 times the numerator of 1. That's a positive 5. Equal to 7 times 35t. Let's see. 7 times 5 is 35. Carry the 3. 7 times 3 is 21. And 3 more is 24. 245. I think that's right. T. Alright, so what do we got here? We've got 35 plus 7, that's 42, and 5 more is 47, equal to 245t. Well, I'm going to divide both sides by 245, and divide this left side by 245. 245's cancel out, and I'm left with t equal to 47 over 245. Pretty nasty fraction. Alright, so let's go on to number 6. And so things change up here. We've done all the fractions. These radicals appear to be really difficult, but in actuality, no big deal. So number 6 says the square root of radical 8q minus 7 is equal to 7. Alright, so what's the inverse operation of taking a square root? It's to square. The inverse of taking a square root is to square. So I'm going to square the left side, and I'm going to square the right side. Squaring undoes the square. That's all that ends up happening here. Squaring undoes the square, leaving me 8q minus 7. 7 squared, well, that's 49. So this gets to be simplistic. So just by squaring both sides, you get rid of the radical. Now you just solve it. 8q equal to, I want to take that minus 7 and bring it on the other side. So this is 49. I'm going to add 7 to both sides. So I get 8q is equal to, what, 56. Divide both sides by 8. And q comes out to be 7. Which, if I look at my answer, letter B. Okay, moving on to number 7. And we've got the square roots. Radical 7q plus 8 equal to 8. And once again, I'm going to do the same thing. I'm going to take this left side and the right side. So when I do this radical here, I'm going to square both sides. Alright, so squaring something under a radical. Take the left side, square it. Take the right side, square that. Squaring undoes. It's the inverse operation of taking the square root. It gets rid of the square root symbol, just leaving me what's called a radicand, the thing that's under the radical sign. And then I got 8 squared, that's 64. And then what we have is something we did back in intro algebra. 7q, if I subtract 8 on both sides, let's see, 64 subtract 8, that's 56. And if I divide both sides by 7, 7's cancel out, and we get 8. And here again, if you were lost, I don't see why you would be, but you could just try each and every answer until you stumbled upon the one. In this case, here's letter B. You know, you can easy enough check it out. I mean, 7 times 8 is 50. 7 times 8 is 56. 56 plus 8 is 64. Square root of 64 is 8. The principal square root, so no big deal. All right, number 8. It's a little bit different, but not that much. You get the cube root. The cube root of x plus 4 equal to 4. If squaring undoes a square root, then cubing undoes a cube root. So I'm taking this left side, and I'm going to cube it. If I cube the left, I got to cube the right. Cubing undoes the cube root, leaving me just the thing under the radical sign. All right. And actually, it's a cubic, but anyways, leaves you the x plus 4. 4 cubed. 4 4s is 16 times 4 is 64. What could be easier here? Subtracting 4 on both sides. I get x is equal to 60. And if I look at my answers, letter 8 is indeed letter A. Hallelujah. All right, number 9. 9 is going to be all that and negatives, whatever that means. Number 9 is this. X is equal to the square root of x plus 13 plus 7. All right, what I need to do before I start squaring to get rid of this radical sign, I need to have that radical all by itself. So what I want to do is bring the 7 over. So we're going to have x minus 7 equal to the square root of x plus 13. Now, what undoes the square root? It's squaring. But here's the killer. When I square the other side, I can't take the two terms separately. I got to treat it as a binomial. And that's how people make mistakes here. I got to square that whole thing. All right, and you're going to end up foiling. People get lazy. They don't want to foil. They want to make up their own maths and wonder why they get it wrong. You got to treat this as a binomial and square the whole thing. You're not just going to square the x and square the 7. Well, a minus 7, that's the easy way out. Foil this, all right? Multiplying, to square something means to multiply this something by itself. Foil. X times x, x squared. Minus 7 and another minus 7 is a minus 14x. Minus 7 squared is positive 49 equal to x plus 13 because squaring got rid of the radical for you. So I see I have a square term which indicates that I'm going to have 2 answers. So if I'm going to have 2 answers, I need to bring everything onto the same side of the equation. So this is x squared minus 14x minus x plus 49 minus 13 equal to 0. So combining like stuff, I get x squared minus 15x. Let's see, 49 minus 13, that's a positive 36 equal to 0. So, factoring this in. Luckily I can factor, I don't need to use the quadratic formula. I got a plus sign here, which tells me my signs are the same. I look here, they're both minus. That tells me minus minus. X minus 3 and an x minus 12. 12 and 3 multiplied would give me a positive 36. Combine a minus 3x and a minus 12x gives you a minus 15x. So my 2 solutions. If x minus 3 times x minus 12 equals 0, either x minus 3 equals 0 or x minus 12 equals 0, giving me answers of positive 3 or x equal to a positive 12. 3 and 12. All right, 3 and 12, but yet you see the, no, you see the answer just being 12. Now, I opted to say, hey, I had a quadratic, which normally means that I have two answers. And, they suckered me in, they will sucker you in, because letter A is 3 and 12. But this is what's happening here. I said checking some of these answers is tough. And this is a case where I need to check both answers because, the letter D is the correct. Now, why is it that 3 doesn't check out? Well, let's see. We go back to the original equation. In place of x, I'll put in 3 equal to the square root of 3 plus 13 plus 7. So this ends up being 3 equal to 16. This is square root of 16, which is 4 plus 7. Well, 3 does not equal 11. So is that what I was saying earlier? Sometimes when you square both sides of an equation, what's called an extraneous, extraneous, extraneous. It's an answer that appears to be right, but in actuality doesn't check out. And the reason it doesn't check out because when we take the square root of 16, if you take the negative square root, which you're not supposed to, it'd be a negative 4. Negative 4 plus 7 would indeed be equal to 3. So what have we learned here? Well, you learned that in some cases when you square both sides, you need to check both answers because letter A has the 3 and the 12, and in actuality, it was just letter D, the 12. So squaring both sides sometimes introduce what's known as an extraneous answer, an answer that... All right, the last one, number 10, we get the cube root. Here again, shouldn't be anything crazy here. This is 3x plus 7 equal to a negative 2. I want to take both sides of the equation. To undo a cube root, I'm going to cube this left side. To undo a cube root, if I cube the left, I need to take a negative 2 and cube that as well. Cubing a cube root undoes the radical symbol here, leaving me 3x plus 7. Negative 2 cubed is a negative 8. If I subtract 7 on both sides, I end up with 3x equal to a negative 15, dividing both sides by 3. The x's cancel out, and I'm left with x is equal to a negative 5. And number 10, if you check your answers, it is indeed letter D. I wasn't worried about an extraneous solution here because I didn't square both sides, so that was a benefit. All right. You'll have only a couple of these problems on the exam because I'm looking, to be quite honest, final exam has got to go back to chapter 1. I'm looking at the neighborhood of 20 to 25 examples. You'll have 2 hours to do it, so...